All right, so we're going to take a look at the 4.6 homework. Definitely, if you still have questions after finishing this up, feel free to ask in class. All right, so number three. So number three, I'm able to factor by grouping. So you can see that I put the last two terms in a group, the first two terms in a group. From this first group, I was able to factor out x squared. From the second group, I was able to factor out -9, leaving me with the matching group of x plus 5. So I've got my factors. I didn't finish factoring my difference of squares. It's up to you if you want to keep doing that. And then I go to make my sign pattern. Now, like we talked about, we know that if the lead term is positive, the last term on the right must be positive. Since this is a third degree polynomial and I got 1, 2, 3 zeros, I know that my signs would alternate every time. Or like we discussed, you can pick any number you want in each zone and test it. I recommend testing it in your factored form just because the multiplication can be very easy at that point. Number 4, I gave you 2 zeros to begin with. Since I gave you them as zeros, I don't have to change the sign when I do my synthetic division. By the time I finish my second synthetic division, I end up with x squared plus 4x, no constant since that term was 0. So that's a pretty straightforward value to factor. Start my sign chart with my 3 zeros. Don't forget about the ones that I gave you. And again, like that last one, if you're using the shortcut, positive lead coefficient, fourth degree polynomial. So my furthest right sign must be positive, and since I got the 4 different zeros, my sign would alternate every time. Again, you're always welcome to check values. Now, in number 5, they've given us a sign pattern and asked us to write the polynomial. First thing that's very easy to overlook, always check the sign furthest to the right. That's going to tell you whether or not you need a negative in front of your factors. From there, I know that I take and change the sign of -1, change the sign of 4. Now, since the solution set focuses on positive values and uses parentheses, I know that I simply want my greater than symbol. Number 6, again, first thing I check, what's the sign furthest to the right? Tells me what sign I'm going to have at the beginning of my polynomial. Take the opposite values from what I see on the sign chart, so x plus 3x minus 1. I look at the solution set they gave me. The solution set they gave me focuses on positive values, uses brackets, so I know that I want to be greater than or equal to 0. Again, number 9, check what you have to start the polynomial. Know that we now start with a positive lead coefficient. Next, I start setting up my polynomial. Now I know that I have x because 0 is a 0, and then my x plus 5, my x minus 5. But I noticed that the sign didn't change as I crossed 0. So I used x squared. In reality, you can use anything you want as long as it's an even number. Next, I look at the solution given. The solution given is focusing on positive values using brackets, and then the single value 0, because I'm going to have something that is greater than or equal to 0. So I've got to include that 0 value as a single term. 17, we're going to solve the inequality. So again, I decided to factor by grouping. Usually if you have a calculator, things aren't factorable. If you don't have your calculator, things are factorable. It's just kind of a good rule of thumb. I take x squared out of my first term. I take -4 out of my second, not term, first group. I take -4 out of my second group. That gets me the matching x minus 1. So I've got x minus 1, x squared minus 4. Again, you could continue on with your difference of squares, but we don't have to. I know that since my lead term was positive, I had a third degree polynomial and I got 1, 2, 3 zeros. I know that I'm going to start with a positive value and alternate signs. I want values that are greater than 0, so I'm going to focus on where my sign pattern is positive. And since it's greater than 0, not greater than or equal to 0, I use parentheses in my interval notation. 23, I gave you a couple zeros so you could start your synthetic division. By the time we finish our synthetic division, we end up with x squared plus x minus 6, which I know factors. and I start setting up my sign pattern. Change the sign of x plus 3. Don't forget the negative 1 that I gave you. Change the sign for 2. And don't forget the positive 3 that I gave you. Again, this was a 4th degree polynomial. The lead coefficient was positive, so I know that it's furthest to the right is a positive value. And then my signs alternate. Or again, you're welcome to test values. We want things that are less than 0, so I'm going to focus on where my sign pattern is negative. Once I see where my sign pattern is negative, I'm able to set up my solution using parentheses since it was less than 0, not less than or equal to. Now, multiple choice number 2 is a good problem to look at. Unfortunately, the correct answer isn't there. But what it tells us is that here is our sign pattern and that this problem has no solution. First thing I can set up is x, because I have a 0 at 0, x plus 5, because I have a 0 at negative 5, and x minus 7, because I have a 0 at 7. Now, since my sign never changes, I know that all of my exponents would have to be even. It doesn't matter what even number, they would have to be even. Since there's no solution, we know that we can't include 0. We can't say that we want to be equal to 0. So now I know that I need a less than or a greater than symbol. And since every single spot on the sign pattern is positive, and we want this to have no solution, I do the opposite of having positive answers, which is less than 0. And again, the answer wasn't given. All right, so if you have any questions still, please feel free to ask in class. Happy to go over anything that we're still wondering about. This wraps up chapter 4. We'll have a test on Friday of next week.